Hello everyone, let us now discuss how can we solve this problem. Count complete subarrays in an array. So this is a simple problem uh, even though it is tagged as a medium one. So you are given an integer array nums consisting of positive integers. So we call a subarray of an array complete if the following conditions is satisfied. The number of distinct elements in the subarray is equal to the number of distinct elements in the whole array. Return the number of complete subarrays. A subarray is a contiguous non-empty part of an array. So, but before that, let us see what are the constants, right? So the constants are low, which means like only 1000, and just nums of I. Don't look at this nums of I, even though it's a lesser number, and just look at this nums dot length is just 1000. Okay, now nums is equal to 13122. This is the first example given for us. Let us see that can brute force work here, right? So let me give you the intuition for brute force first. So firstly, I'll take how many distinct elements are there in this array, right? There is 1, there is 3, and 1. Okay, 2, yes, 2. So totally there are 3 unique elements. So there are 3 unique elements in this array, right? Now let us take, for example, let us take in a subarray, right? I am taking this subarray, just this subarray, and let me go and generate all the subarrays, and let me take how many distinct elements are there in that subarray. Here I have 1, so the number of distinct elements in my subarray is just 1. Okay, now I am taking 1 and 3, so the number of distinct subarrays, or sorry, elements in the subarray is just 2, but we need 3, then we will increment our count. So let me also initialize my count is equal to 0, right? Now let me take another subarray, right? 1 3 like 132, right? 1312. Now here I will get 1 2 and 3. These are the unique elements in the subarray. So 1 2 3, so the count is 3, and the total unique elements in the subarray is also 3. So I'll just increment the count by 1. Now let me take another subarray. From here, starting, I am starting my I here and going and went till here. Then 1 comma 2 comma 3. So totally I have 3 unique elements in the subarray. So I'll increment the count. Now the count is 2. Now let us see, if I started here, then I will have only one uh, distinct element in the subarray. Okay, it's not a complete subarray, right? 3 1, so 1 comma 3, right? So we are having only 2 as the count of distinct elements in our subarray, so don't increment our count. 3 1 2. So I'll use a set to store the elements in the subarray 1 2 3. So the count will be incremented, the count will be incremented to 2, sorry, by 1, then it will become 3, right? Okay, now let me take another subarray 3 1 2 2. Here also I have 1 2 and 3, right? Totally I am incrementing the count, so it will become 4. Now even if I start here, I will not get any subarrays which are complete. Why? Because we are missing a 3 here. Now I'll tell you how we can even optimize it, but before that let me write the algorithm here, right? So the algorithm is take unique elements set which contains the unique elements in the array. Now iterate from I is equal to 0 to n, right? For I is equal to 0 to n, and also for j is equal to I to n. So here I will initialize our temporary set. Now let me do one thing here, right? Here I am taking this set, and now in this set I am taking the array element into the set, right? Temp dot insert array, sorry, it's nums, right? Nums of j. So if temp dot size is equal to unique elements dot size, unique elements dot size, then I am incrementing my count. That's what I did there, right? Count is equal to 0. So right here I have got all those count. Now after that I'll simply return the count. So it will take something like big O of n square time complexity, and I am taking unique elements. That means maybe like big O of n for unique elements, right? So here also it might not be concerned, like it is the biggest one. So the space complexity will be big O of n, and the time complexity will be big O of n square. Now let us look at another example, and let us use a sliding window algorithm here. Now let us see what. So imagine my window is something like here, right? Now the total unique elements, right? The total unique elements in the array are just 3. Okay. Now in the window I have 2, 1, 3. So what I am saying is this is one complete subarray, right? This is one complete subarray. What I am saying is this is one complete subarray. Now if I take 2 into consideration, right? Okay, 3, it is 3, right? There are 3 unique elements, and the 3 unique elements are there in this window. Okay, in this window I got 3 unique elements. Now if I take from here till here, so is it a complete subarray? Absolutely yes. Why? Because let me say that even if taking 2, I got unique elements that 1, 2, and 3. Now, let me take this also. Now, what I am considering is the subarray from here till here. Okay, so from here till here. So, I think you got it right. 1, 2, 3 are the subarrays till now. Now, till here also I am taking from here to here. So 2, 1, 1 to 3, right? So the number of unique elements are still 3, right? Now let us see what is happening here. So imagine you are just taking this subarray. I got to this window. Now till here, okay, it is a complete subarray. Now, what I am saying is even if I add these elements, then I will only contain from here till here. I will not contain any numbers either than 1, 2, and 3. You might ask me why. Why? Because if I had something like here, I am saying that this window dot size, right? So window is nothing but a hash map. I'll tell you in when I go to the algorithm. But here the number of unique elements is equal to the number of unique elements in the whole array. But you might ask me what instead you are taking that this will also be a unique complete subarray. This will also be a complete subarray. But you might ask me if there is a 4 here, what will it might be? Then this will not be our complete subarray. That's what I want to tell you that. So if I have, this is the first intuition. If I have window unique elements, your window unique elements is equal to total unique elements, then I am incrementing count plus is equal to, just imagine that here I am pointing my right pointer, here I am pointing my right pointer, and here I am pointing my left pointer. Okay, now let us see. Left pointer is here and the right pointer is here, and here will be the end. So here it will be n. Now how many good complete subarrays that I can generate? N minus r. That's what I said. This is one complete subarray. This will be one complete subarray. This will be one complete subarray. Let us see by indexing 0, 1. Let me remove all these things. It's quite clumsy over there. Right. Okay. Now this will be n, and I took this window 0. Wait a second. Here it will be 1. Now here it will be 2, 3, 4, 5 and 6. So the window is here and right is 4. Now what I am saying is 7 minus 4 are the total number of complete subarrays with this window. Let me check. This is one complete subarray. This is one complete subarray. This is one complete subarray. Yes, absolutely yes. Right? Now here count plus is equal to n minus r. Now I got something like, okay, I got something like, now I just go and increment the left pointer every time. But let us take how I am taking this window 1 to 1 3. Okay, okay, right, 1 to 1 3. Okay, now let me do the indexing again. 0 1 2 3 4 5 6 and 7 is the size of n. It's not the index, it will be out of bounds, right? 1 2 1 3. So the total number of elements, right? The total number of unique elements are 3, and also the total number of unique elements in the whole array are 3. So these both are equal. Now what I mean, what if I just shrink the window? Whenever I am solving this something like this, what I'll tell you, sliding window, the main intuition is when to expand the window and when to shrink the window. I just go and expand the window by using r with a while loop. But before that, let me tell you how I am incrementing or shrinking the window. This is the window I got. Now what I am saying is, from here till here, from here till here, I got a window, right? What I mean exactly is just something like from here to here. Now, what if I just shrink over here? Now, the number of total unique elements are still 3. So, if I didn't shrink any window, then I will miss this window, right? So, I will miss this window. So, when to shrink is at this point. So, if I have window unique elements is equal to total unique elements, then I need to shrink the window. So so let me completely write the algorithm. I will use unordered map. So unordered map, one for unique elements. Unique elements is nothing but here the count of this 3. But instead you can take a set, right? Set of int. I'll write how it will be. I'll just change this with the algorithm. Taking this algorithm set int st. So instead I am naming it as unique elements. Okay, unique elements of nums dot begin comma nums dot end. Okay, okay, so it will be unique elements will have total unique elements in the array. Okay, now I am taking an unordered map. Unordered map is nothing but, I'll tell you what is this unordered map. Unordered map is nothing but storing the numbers or the count of frequency of the numbers. For that we are using unordered map. I am naming it as window. Now I am initializing L is equal to 0, R is equal to 0, while R is less than N. For that I forgot, wait, I forgot N is equal to nums dot size. Okay, while R is less than N, R is less than N. So unordered map we stored like window of nums of R plus plus, and at the last we'll be incrementing our R pointer. But if I have window unique elements is equal to total unique elements, then I need to do something. Count plus is equal to n minus R. Here we are shrinking, wait a second, here we are shrinking our window. So shrink window, right? So window stores nums of L minus minus. So if window of nums of L is equal to 0, then window dot erase nums of L. Okay, now count plus is equal to n minus R. Here I am incrementing my left part. This is the whole algorithm. Let us see whether I will get a correct solution for this array, right? I am just making a copy of it. Now let us see, let us do a dry run here. Right now at the last I am so I think I forgot here to initialize count is equal to 0. Okay, at the last I'll return count. Okay, so firstly left is equal to 0, right is equal to 0. And now I just take left and let me take unique elements size is 3, right? Okay, unique element size is 3, and in my window is empty for now. Window is empty for now. So the left pointer is here, the right pointer, let me name it as L and R. The left pointer is here and the right pointer is also here. Okay, while R is less than N, yes, true. Window of nums of L plus plus. Window of nums of L, 1. Okay, 1 is present for one time. Now, if I have window unique elements, that means window size is equal to total unique elements. Let me change it. So, window size is equal to total unique elements. No, it's not equal, right? We have only one here, but we have 3 for unique elements, so they both are not equal. So just increment our right pointer. I am incrementing our right pointer. Here I got 3. Now what I am doing, while R is less than N, yes, true, window of nums of R plus plus, nums of R 3, so 3 is so it will be increment. This is how the unordered map will work if you didn't solve any unordered map question. If I have window size is equal to total unique elements, no, they are not equal, so I will not go to this condition. But here I need to place a while loop. Why? Because I am just going till I get 1 1 2, something like 3 1 and then 2. So if I am having this, then this can also be total unique elements complete subarray. This can also be a complete subarray. That's why I am going from here till here. So it is the last complete subarray. I don't get any subarray after that. So that's what I am going through this while condition. Now it's not valid, so it doesn't go to there. Now R plus plus, so I am incrementing R the here. Now windows of nums of R plus plus, I am just incrementing nums of R is 1, so it will be incremented by 1. Now window size is equal to total unique elements. It's true? No. R plus plus, let me do that. R plus plus, okay, I got to 2. Now I have, while R is window of nums of R plus plus 2, I didn't got till now. Okay, 2 for one time, just incremented. Now while I have window size is equal to total unique elements. Yes, I have window size is equal to total unique elements. What I need to do, shrink window, window of nums of L minus minus. Nums of L is 1. I am just decrementing the count by 1. I got 1. Okay, if window of nums of L is equal to 0, I am erasing that from my window. No, it's not 0. Count plus is equal to n minus r. Okay, that from till here I got something like just I'll tell you 0 1 2 3 4 5 5 minus 3, just I got 2 as the count. So I am incrementing the count is equal to 2 for now. Okay, the count is equal to 2 for now. Okay, after incrementing the count L plus plus. Okay, I am just incrementing the L till here. Okay, now let us see. Ah, so here, while I have window size is equal to total unique elements. Now let us see. Window size is equal to total unique elements. Yes, it's true. Now shrink, but shrink window, windows of nums of L minus minus. Let me do that. Okay, I got 0. Now, if window of nums of L is equal to 0, window dot erase nums of L. Oh, sorry. Nums of L is 3, right? Nums of L is 3. 0, right? If windows of nums of L is equal to 0, window dot erase nums of L. So I am erasing nums of L. Okay. Count plus is equal to n minus r. R is still 3 and n is 5. Count plus is equal to 2. 5 minus 3 is 2. Then I'll get 4. Okay, window of nums. Okay, count plus is going L plus plus. Now I am incrementing L plus plus. Now I have, while I have window size is equal to total unique elements. Is it true? No. R plus plus. Let us do it. R plus plus. Now I have nums of R is 2. Then I am incrementing the frequency of nums of R, which is 2 to 2. Now window, while I have window size is equal to total unique elements. Is it true? No. Right plus plus. Right plus plus, it go out of bounds. I'll stop here. This is how you solve this problem by using this algorithm, right? If you have any doubts, please don't hesitate to comment in the comment section. And if you like this video, do share it to friends and do subscribe to my channel. Thank you.